to go. These ones have been carefully curated for you guys. We think that this should be exciting enough to get those who are not in IB interested in trying to get a project together for the science fair or whatever. So yeah, do you want to take it away, Joel?
But IB people, if you see something that's interesting to you, got it. Yeah. If you see something that's interesting to you in IB, you know, you can potentially work as well on an individual IB project. So pay attention.
Right, so hello everyone. My name is Eduardo, and my partner will be Joel, but he's not here today, but he will be here next time we meet. To tell you a little bit about myself, I actually graduated from Andrew Hill in 2009. From there I went to San Jose City College, transferred to UC San Diego where I studied chemical engineering, and I'm now studying chemical engineering at Stanford. And my partner Joel is also a California native. He is from Modesto, went to Modesto Junior College, transferred to UCR, also studied chemical engineering, and is also now at Stanford University doing his PhD in chemical engineering as well. So today I want to talk to you about renewable energies for cars, so alternative sources of energy to power a car. Can anyone name some alternative fuels that are being used at the moment? No? Okay. We have a hand back there.
Electric cars.
Exactly, electric cars. That's a very popular one, like Tesla, for example. And to give you the answers, so biodiesel, which is derived from vegetable oils. We also use natural gas. We can also use corn to derive ethanol. And hydrogen, and as someone mentioned before, electricity. But I want to focus on hydrogen-powered cars. So currently, hydrogen is produced from oil refineries or fossil fuels. And with that comes a deficit in terms that we produce a lot of CO2 in trying to produce hydrogen for energy. So there's kind of a balance there. But there's being research done to produce hydrogen in a clean manner. One of the alternative methods that could be used to produce hydrogen is using an electrolyzer, in which water is your reactant and you split hydrogen and oxygen, and from there comes your hydrogen source. And this hydrogen can be applied to fuel cars using a fuel cell. In the picture on the right, we have, it's working backwards, but if you go from left to right, you feed hydrogen to the fuel cell. The electricity is taken out from the hydrogen. The hydrogen passes through a membrane in which only positive ions are allowed, and the electrons have to go through an outer circuit. And in this journey through the outer circuit, it provides some type of work, and it recollects on the other side, in which is mixed with water, and its only byproduct is, it mixes with oxygen, and its only byproduct is water. And to show you an example of how it can be applied to cars and what it can do, I have a little video to show you.
A human being can survive 3 days without water. Here, it's only 14 hours.
Your last moments in civilization, how you feeling? Today, we are going to travel through the wilds of Death Valley, surviving only on the water produced by our car.
The F-cell engine runs on compressed hydrogen. Its only emission, water vapor. We attached a tank to the car to collect its emissions.
This is all we want for the next few days. Okay, last water.
The ultimate test for Diane and Joshua, and for the future of emission-free mobility.
Explore the Death Valley.
It is hot.
Yeah.
3 hours after they started, the moment of truth. Is it really possible to drink a car's emissions?
Heads it is. These were the last moments.
It looks like water.
Here goes. Everybody says.
So it's only fun.
Good.
Yep. We're saved!
That's wild. That's crazy. Our car makes water. Drive around, make some water.
Take a shower?
That's sort of anticlimactic. I was expecting drama or death on the sideway. I don't know.
Wait for me! That has absolutely no taste.
After 2 days and 21 liters of emissions consumed, the most unusual car test came to a happy end.
Surviving Death Valley.
I'm not sure that you're going to be able to get like power windows, leather seats, and a water pump, but the technology is there.
Yes.
A human being.
So as you can see, if we're able to make hydrogen cleanly, we can maybe in the future eliminate even using any type of fossil fuel. And as you can see, the only byproduct from using hydrogen as an energy would be water. So if anyone's interested in renewable energy, I'd definitely be interested in working with any of you.
Okay, that's it. Can't hold all these things. Okay. Hi, so my name is Ruby, and I'm working with Charlie, who's right here. We're also interested in renewable energy, so I think the talks by Alan and by Eduardo sort of lead into this really well. So I work in the material science department. I'm also a physicist, and Charlie, you work in biophysics, right? And you also did your undergrad in physics. So we're interested in working with you on different ways of collecting, using, and transforming energy. Okay, so one of the projects that we thought of, just as an example, just to get people started thinking about this, is to think about how to more efficiently collect solar energy from the sun. And outside in your very own parking lot, there are some solar panels outside, and you know, if you could actually point those solar cells right at the sun all the time, like in this picture where we have a picture of a solar tracking mechanism. So that's some sort of motor that actually moves the panel, you know, and rotates it so that it's always pointing at the sun. That would be something that would be pretty cool to build and measure and see that you can actually improve the amount of energy that you can collect from the sun that way. Another similar idea is to use solar concentrators. You might not have seen these, but these are mirrors and setups in a specific geometrical shape which focus and collect the sunlight into a central location in the middle. That's what's called a solar concentrator, and that can also really increase the solar output that you can get. So those are two example projects. But in general, other ways of using, like collecting energy, such as wind or flexible solar panels, those are really cool to work with. I also know a lot of stuff about batteries, if that's of interest. And in general, other things other ways of collecting renewable sources of energy are what we're interested in. Yeah.
All right.
I'll hold this.
Hi everyone, I'm Charlie, and I'm especially interested in forms of energy that are renewable but sort of not what you typically think of when you think renewable energy. So we've heard a bit about solar and wind so far, but there's energy everywhere, and a few of the places you could imagine trying to harness some of this energy from are things like friction, just in your daily life when like your clothing rubs against other pieces of clothing, or things you could imagine trying to use the energy from that process to power a device. There's a few others, like a good example is self-winding watches that wind themselves up just based on the kinetic energy of you moving your wrist around. There's radio waves everywhere, so people have built these devices that literally suck the energy straight out of sort of nothingness, just the electromagnetic radiation around you. And the one that I'm interested in working on and focusing on is actually harnessing energy from the simple process of water evaporating. And this involves using these bacterial spores, and that should say tape actually, it says tap. But using very simple materials you can get energy. So I'm just going to tell you a little bit about how this works. So these are pictures of bacterial spores, which are single bacterial cells that are encased in this rigid coating. And you can see they look a little shriveled up. And the reason is because they're in a dry environment. So when they're dry, they shrivel up. And then if you expose them to more humid air, they're going to expand. What you can do is you can put a bunch of them on a piece of tape. So that yellow thing is tape, and then this stuff above it are these bacterial spores. And if you do that, what happens is when they're dry, they're curved, and when they're humid, they extend. And if you build a chain of these things, you can get a piece of tape to expand and contract in response to water. And people have built engines out of this, and in this first video, they built an artificial muscle, that's what they call it, out of this. So you can see that just by cycling the humidity of the air, dry versus wet, you can get this thing to lift weights. So they just pull the water out of the air. And on the right, this is an engine that powers itself simply on the evaporation of water. They just pour water into it, and you'll see in a second that these shutters begin to open and close, and if you were to plug a light bulb into this thing, you'd see that it lights up. So this is one model, and then one model for a device you could use. And then we'll just show a few seconds of this. They were actually able to build an engine that powers a car based just on the evaporation of water. So this is done with pretty simple materials. And I think it would be a really cool project to work on with some of you who are interested. And there's all sorts of questions we could begin to address. Yeah, so that's all I have. Thanks.
It's okay, yeah. It's good. Okay, I'll go first. You get to
Hello? Okay. So my name is John Lynn. This is Ruben Brutto. We're in the chemical engineering department at Stanford. First year PhD student. Ruben's a third year, right? Yep. I wasn't expecting Ruben to be here today, so that's why his picture's up there of mine isn't. But he's here, which is awesome. So we're also talking about renewable energy. Our research group at Stanford does a lot of renewable energy projects. I'll try to make it a little different from what you've heard before. Boring statistics, right? But what you can't see, it probably getting covered up in the corner, is that 80% of our energy comes from fossil fuels. And we all know that there are problems with fossil fuels, global warming and all that. And you might think, oh, well, we're in this world where we have solar cells and everything's renewable. But actually, as recently as 2 years ago, only 10% of our energy comes from renewable sources. So we still have a long way to go in making the transition from fossil fuels to renewables. It's also, I guess my titles are all wrong there up at the top. That says fossil fuels are both good and bad. And like I said, we still use a lot of fossil fuels. Why is that? It's because they're actually really cheap and convenient. You can run a sports car on gasoline. It's harder to do on electricity from a battery. In terms of all the electricity we're using in this room, what runs this school, what runs the city, electricity from a coal-fired power plant is just more practical than electricity from solar cells at this point. And of course, we all know about the problems with CO2. I assume you guys all believe in global warming. But the fact is, the measured CO2 concentration in the atmosphere has been spiking. So just in the last 50 years, it's increased, I don't know, from 300 to 400 ppm. Okay. And you've heard a lot about the different alternative energy sources that we could look to replace fossil fuels. And you might be wondering, well, what's the best one? What should we put our effort into? And I'm not claiming to know everything here, but one statistic that always jumps out at me is that more energy from the sun hits the Earth in 1 hour than all the energy we consume on the Earth in an entire year. And that's why solar energy has a lot of scientists excited. If we could just harness that solar energy and convert it into useful forms, maybe that would solve all of our problems. And then I have this link at the bottom here in red. That's a link to a speech that was given by this professor at Caltech, Nathan Lewis, that really inspired me when I was sort of more or less in your shoes. It's
explaining why we want to harness solar energy as sort of the best alternative.
You hold this in your hand too.
Sure. Okay.
That's how people who aren't here are going to be able to know what.
Oh, okay. All right. Well, I'm not going to repeat it all.
No. I'm sure they got it.
Okay. And then, if solar energy is this great alternative, what ways are we harnessing solar energy? So obviously solar panels to make electricity. You can use mirrors to actually focus solar energy and just heat up a tower of water and make electricity the way you would in a normal power plant. You could also go the biological route and use photosynthetic algae that make fatty molecules that can be sort of turned into gasoline. So in terms of like project ideas, things that would be sort of amenable to something you guys could do with what you have available, we're trying to think of what are some of the big issues, things to get you thinking about. We're pretty good at making electricity from solar energy, but you have to use, like, electricity supply and demand has to be like matched instantaneously. When you make it, you have to use it, unless you can store it. And right now we have batteries. In Europe, especially, when they make solar energy in a place like Denmark, they'll use it to like pump water uphill so that they can sort of have run the water downhill later and make electricity from that. And what we get really excited about in our lab is storing energy in chemical bonds. And I actually have a video here. It's this in the upper right. Can somebody click on it? I hope it works.